Welcome back students to Standard 10 Chemistry Chapter 2 Acid, Bases and Salts, and we are into the second session. Alright children, in the previous session we just saw how to derive the chemical formula, or as we call them as molecular formula of acid, bases and salts. Alright, having learned that, now we begin the main chapter. Alright, fine children, if you go to a grocer's shop, right, and ask for wheat, in your list you have wheat, sugar, toothpaste, right, bathing soap, oil, ghee, and say suppose few biscuits. Alright, so these are the list. You tell the attender in the shop to give all these 6 or 7 articles. How much time will he take to give you? Will he have to search all the things? Will he make a mess while searching the things? Will he take time while searching the things? Can he find these things very quickly? And you might say, yes. Why? Because all the things are classified and well arranged in the shop. He knows where particular biscuits that you have asked for are lying. He knows where the wheat is. He knows where the oil is, where the ghee is, where the bathing soap is, where the toothpaste is. Correct? Because everything is well arranged. You will find all the toothpaste of different companies placed in one shelf. All the bathing soaps, they will be kept in other shelf. All the pulses, they are kept together. All the cereals, they are kept together. Oils of different companies, they are kept together in one corner. Correct? So it is very easy for him to find the articles and give you, because all these articles in the grocer's shop are classified and well arranged. Now imagine you went to another grocer's shop where all the things of your list were kept randomly. With biscuits, the soaps were kept with soaps. Well, even the toothpaste were kept. Alright, with pulse, cereals were kept. With oil, there were some other articles, all mixed. Alright, that's why he will take a lot of time to find the things, because he doesn't know exactly where the article is lying. Alright, so because he will take time, why he will take time? To search. That means he is spending more energy also, and he has made his work tougher. The work becomes tough to find those articles and give you. Let's take another example. When you go to buy medicine, alright, at medical store, does he take any time to find the medicine? Not that much. Alright. Do you know how the medicines are classified in a medical store? By the name alphabets? No. The people attending to you to give the medicines, alright, in the medical store, they have knowledge about medicine. Okay, they are pharmacists, alright, matlab they have learned pharmacy, so they have knowledge. Alright, so when the doctor gives you prescription and when you go to the medical store for it, when they read the medicine, name of the medicine and the company, they know this is disease related to heart, or this is disease related to lung, or this is disease related to kidney. मतलब वो disease किसके related है वो उसको पता है, क्योंकि उसने study किया है. They have that knowledge. Alright, ठीक है. तो all the medicines related to kidney disease are kept at one place. All the medicines related to heart disease are kept at other place. So when they read the medicine, name of the medicine from the prescription, They know, oh, this is lung related disease. So they will go to the counter or a shelf where all medicines related to lung diseases are kept, and they will take little time to search. Okay, then they may be arranged in alphabetical order on basis of ABCD. And say suppose the name of the medicine starts with W, तो वो तुरंत वो W वाली sequence में से वो medicine निकाल देंगे. So here also the medicines are classified, और उससे फायदा होता है. The work becomes easy. Yes, you spend less time, and yes, you are saving your energy also. Okay. So classification का बहुत ही फायदा है. Correct? Your mom, when she's preparing different dishes in the kitchen, all right, maybe on the containers the names are not written कि यहाँ sugar है, tea है, okay, chili powder, धनिया powder, or pepper, right, whatever, cardamom, ऐसे सब डिब्बे पे लिखा नहीं होगा, कहीं पे लिखा भी होगा, but at most places you will not find those containers are labeled with the articles they contain inside, all masalas. But say suppose your mummy wants salt, she will pick up the container without any hesitation, without any delay. If she wants tea, वही container लेंगे, chili powder वही लेंगे. You understand? जो भी चाहिए, she will easily pick up the container because she knows where she has kept all the things, because they are classified. All masalas are kept together. All pulses are kept at other place. Wheat, jawar, rice, whatever, they are kept at other place. Different types of flour, they are kept at other place. Oil, different place. Ghee, different place. Vegetables in the freeze, refrigerator. Correct? So everything is well classified and kept. So the work becomes faster. You are saving energy and also the time. Okay? Not only fast, but the work becomes easy. So that is the importance of classification. So here my question is, why classification is essential? The question is already answered. It makes our work easier, faster, saves time and energy. Correct? So more than 300 years ago, the scientists, all right, they decided that all the things that we use in our day-to-day lives, all right, all edible things, all right, not even the non-edible things, all right, which we use for various purposes should be classified, all right, okay. And yes, many scientists gave their theories, all right, and the theories had some limitations. उसके कुछ फायदे थे, कुछ गैरफायदे भी थे. There were some limitations. Yet, the most appropriate or most acceptable theories of this classification was for the first time given by Robert Boyle. Robert Boyle. In 1611 AD, he was born. He was born in this year. But, alright, it's not mentioned at what age. But he classified the things into acid and base. Well, this was the first theory. Before him also, some scientists may have given theories of this classification. But his was the first most prominent theory which people accepted. The other scientists accepted. उसकी भी limitations थी, लेकिन first theory that became popular was Robert Boyle's theory. This theory was based on properties of substances. It was based on properties of substances. Alright? Kuch property, okay. Now what do you mean by property? Please try to understand this nicely. Alright? Okay? Well, it's a recess time and you are playing on the ground in the school. Alright? And some visitor, a stranger, comes to you and asks, I would like to see Prakash sir. Where can I see him? Alright. Now, well, you might explain my property, okay? you might tell that stranger, all right, you go on the second floor staff room. In the staff room, you will find a male with beard, medium height, well, maybe 60-70 kg weight. There is baldness in front, पूरा cover खुला है, all right. He has spectacles, all right. Okay, चलो, आपने मेरा थोड़ा description दे दिया. You have given my property to that stranger. Now that stranger comes to the second floor. It was recess time, so all the staff members, they were sitting in the staff room, but still that stranger came right to me and asked, "Sir, are you Prakash, sir?" I said, "Yes." And I don't know the stranger. Oh, koi parent tha. Anyway, see, the property that you described, yes, enabled that stranger to reach directly to me. Again, he did not have to ask anybody. Are you getting me? So that is property. Property से आपने identify करवाया मुझे. आपको समझ में आ रहा है? Right. So like that, हर substance की खुद की अपनी properties होती है. So on the basis of property, well, Robert Boyle divided, classified, grouped the substances into acid and base. Okay. उसको हम आगे डिटेल में थोड़ा देखेंगे, लेकिन अभी मैं just orally I am telling you, those substances which are sour in taste, जो स्वाद में खट्टा है, all right, which turns blue litmus paper red. आप उस सब्सटेंस पानी में डाल के सॉल्यूशन बनाओ और उसमें मॉइस्ट, ओके, लिटमस पेपर डालो ब्लू वाला, और वो रेड हो गया, देन इट इज एसिड. द सब्सटेंस विच इज कोरोसिव टू टच, आप उसको टच करेंगे तो कोरोजन शुरू हो जाएगा, ऑलराइट, ओके. देन मेटल का नहीं, हमारी स्किन का भी. अभी आप concentrated acid which you used in your bathroom toilet to clean, if it falls on your finger, your skin will burn off, all right, that is corrosion. वहां खड्डा गिर जाएगा, right, that is corrosion. So it is corrosive to touch. Sour in taste, it turns blue litmus paper red, okay. So ऐसे substance जिसमें ये property है, Robert Boyle called them as acid. चलिए, बेस की बात, it is bitter in taste, all right, okay. यहां कुछ examples मैंने बताया था, ऑर्गेनिक एसिड, लैक्टिक एसिड इन कर्ड, ऑक्सैलिक एसिड इन टमेटो, वो अब मैंने नहीं लिखा था. जो टमेटो की सारनेस है, दैट इज प्रेजेंस ऑफ ऑक्सैलिक एसिड. टैमरिन, उसमें टार्ट्रिक एसिड है. एप्पल, उसमें मैलिक एसिड है. विनेगर, उसमें विच एसिडिक एसिड है. देन लेमन और ऑरेंज, उसमें साइट्रिक एसिड है. So here all these things are sour because they are acid, all right. चलिए, base, they are bitter in taste. Your soap water, when you are having bath, taste the soap, you will get bitter taste. वो base है. It turns red litmus paper blue. आप सोप का सॉल्यूशन बनाइए, उसमें moist red litmus paper डालिए और निकालिए, it turns blue, all right. Then this is slippery to touch. चिकना होता है, उसको हाथ में लगाओ चिकना लगेगा, इसको हाथ में मत लगाओ, it's corrosive, dangerous, all right. So on the basis of properties, the things are classified as acid and base by Robert Boyle. Did you get my point? All right. After that came Arhelius theory. Arhelius theory. After Arhelius came, Laurie-Bronsted theory and Lewis theory. All right, children. यहाँ लॉरी और ब्रॉन्स्टेड दो अलग साइंटिस्ट थे. They were different chemists. One from Denmark and other from इंग्लैंड. ऑलराइट, ये दोनों साइंटिस्ट ने साथ में एसिड बेस थियरी दी थी. ऑलराइट, Now let's talk about this theories in brief. Then I'll give you detailed information about it. Children, yes, ये तीनों थियोरी की अपनी अपनी एडवांटेजेस और डिसएडवांटेजेस थी. वो भी फुल्ली क्या परफेक्ट थियोरीज नहीं थी. फिर भी आर्हेनियस थियोरी या हिज वर्क वाज कंसीडर्ड टू बी ग्रेट. उसकी थियोरी बहुत चली थी और 1903 में उसको नोबेल प्राइज मिला. चिल्ड्रन, Arhelius received Nobel Prize in Chemistry in 1903 AD. Do you know what is Nobel Prize? It is the highest award that one can get on the earth. पूरी दुनिया का अवार्ड होता है Nobel Prize. So Nobel Prize in Chemistry was received by Arhelius in 1903. This theory came in 1923 और ये theory भी 1923 में आया. Do you understand? Okay. Children, let me talk about Arhelius acid-base theory. According to Arhelius, take the substance which you want to identify as acid or base. If it is soluble in water, dissolve it. पानी में डालो और उसका solution बनाओ. That is called aqueous solution. पानी में डालकर बनाया गया solution को बोलते हैं aqueous solution. All right. Now, when you add this substance into water, ionization takes place. आपको पता है, like sodium chloride, तो Na+1 Cl-1 दो आयन्स अलग होंगे. जैसे वो आयनिक कंपाउंड जुड़ के बना था, अब वो अलग होगा इन द फॉर्म ऑफ आयंस. दो ऑपोजिटली चार्ज आयंस जुड़ जाते हैं आयनिकली बॉन्ड से आयन या ओके और कंपाउंड बनता है. लेकिन यही कंपाउंड जब हम पानी में डालेंगे तो आयनिक बॉन्ड ब्रेक्स एंड यस द कंपाउंड डिसोसिएट्स, अलग होता है, स्प्लिट होता है इनटू पॉजिटिव आयन एंड नेगेटिव आयन. ऑलराइट, सो व्हेन यू टेक द सब्सटेंस, prepare its solution in water. During ionization, if one of the ion is hydrogen, then according to Arrhenius, that is acid. That is acid. जो भी substance पानी में solution बनाएंगे और hydrogen ion देंगे during the dissociation, then it is called acid. But if one of the ions produced is hydroxide, आपको ये easily समझ में आएगा क्योंकि मैंने बताया cat ion is fixed in acid and that is hydrogen. N ion is fixed in base and that is hydroxide. So when you prepare solution, all right, if one of the ion produced is hydroxide, then according to Arrhenius, that substance is base. So this was all about acid-base theory of Arrhenius. उसकी limitations थी. What about those substances which do not dissolve in water? Whether it is acidic in nature or basic in nature, his theory could not tell that. Do you understand? And there were few substances like ammonia. All right, ammonia you dissolve in water. No hydroxide, no hydrogen ion is produced. All right, no hydroxide ion is produced there. वहाँ hydroxide ion produced नहीं होता है. When ammonia is dissolved in water, hydroxide ions are not produced, but still the substance is basic in nature. ये रॉबर्ट बॉयल के हिसाब से हम वो रेड लिटमस पेपर उसमें डालेंगे सॉल्यूशन में, इट टर्न्स ब्लू. उसको टेस्ट करेंगे बिटर, उसको हाथ में थोड़ा मसल देंगे तो स्लिपरी. सो रॉबर्ट बॉयल के हिसाब से वो बेस है, लेकिन आर्हेनियस के हिसाब से वो बेस नहीं है. क्यों? क्योंकि हाइड्रोक्साइड आयन प्रोड्यूस ही नहीं हुआ. तो ये लिमिटेशंस है. यस, द ट्रूथ इज ammonia is basic in nature, but Arrhenius theory does not explain that. Okay, so Arrhenius theory की भी अपनी limitations थी. So to overcome Arrhenius theory, Lorry-Bronsted theory came into existence. लॉरी और ब्रॉन्स्टेड दोनों ने मिलकर नई थियरी बनाई जो आर्हेनियस की एसिड बेस थियरी की लिमिटेशंस को ओवरकम किया, निकाल दिया. ऑलराइट, उसने बहुत अच्छी तरीके से प्रूव किया कि व्हाई एमोनिया इज बेस. ऑलराइट, चलिए Now what was their theory? All right, children, double time I will be okay, short में कह देता हूं. ये substance 1 है और ये substance 2 है. This substance 1 donate proton. All right, ये substance 2 को proton देता है. ऐसा हुआ तो this substance is acid, one which donates proton. इसने donate किया और इसने receive किया, receives proton. Right? जो proton receive करता है that is Lowry Bronsted base, और जो proton donate करता है that is Lowry Bronsted acid. This was their theory. All right. The next theory, Lewis, it also came in 1923. जैसे मैंने बताया इस theory की भी कुछ limitations थे, and those limitations were overcome by Lewis. देखो, substance 1 and substance 2. ये substance 2 donate a pair of electrons. और this one receives. It receives a pair of electrons. जो डोनेट करता है प्रोटॉन वो एसिड है, यहां जो डोनेट करता है इलेक्ट्रॉन वो बेस है. ऑलराइट, द वन सब्सटेंस विच रिसीव्स प्रोटॉन, जो प्रोटॉन एक्सेप्ट करता है वो लॉरी ब्रॉन्स्टेड बेस है. लेकिन अकॉर्डिंग टू लेविस जो पेयर ऑफ इलेक्ट्रॉन रिसीव करते हैं वो एसिड है. सो वी आर नॉट गोइंग टू लर्न अबाउट दिस थियरी. लेविस की थ्योरी के बारे में कोई चर्चा आपकी टेक्स्ट बुक में नहीं है, मैंने थोड़ा एक्स्ट्रा आपको बता दिया. सो वी विल बी डिस्कसिंग इन डिटेल अबाउट आर्हेनियस थ्योरी, लॉरी ब्रॉन्स्टेड थ्योरी, एंड ऑल्सो यस द थ्योरी of classification of acid and base by Robert Boyle on the basis of chemical properties, on the basis of properties of substances. All right, so let's see further little bit in detail. Okay, so children, let us see the concept of acid and base little bit more in detail. All right, as I discussed, Robert Boyle in 1661, he was born in 1611, but this theory was given in 1661. He characterized acids and bases. Bases are also called alkalis, right? Okay, as I discussed, acids, the substances which are sour in taste, the substances which are corrosive to touch, and the substances which change the red litmus paper blue. There is error, copy paste किया गया था. So not red litmus paper but blue litmus paper into red. Remember, red is a color which symbolizes danger, and acid is dangerous thing. That is what is the basic या normal Alright, so red color is basically showing you the sign of danger. So people normally think that acids are dangerous, right? It is not so. There are, as we have learned about organic acids, they are found in edible substances, correct? Okay, anyway, but this red color will help you to remember that acids are dangerous. Yes, blue litmus paper turns to red. That red shows danger, right? Okay, what about base, alkali? They are bitter in taste, they are slippery to touch, and they change the red litmus paper into blue. Children, कोई भी substance आप ले लो, उसको water में डाल के dissolve करो, so you are going to get a solution. In this solution, you have to take litmus paper. उसको पहले wet करना है, moist करना है. Take litmus paper, put in water, so the litmus paper gets wet. उसे कहते हैं moist litmus paper, and that moist litmus paper, when you introduce in that solution, if blue turns red, then that solution is acidic. If red turns blue, then that solution is basic. Alright, okay, as I discussed, many scientists made attempt to classify the things, all right? So one of them was Antoine Lavoisier, all right? According to his theory, all acids contain hydrogen. What this scientist believed? He believed that all acids contain oxygen. Say suppose HNO3, H2SO4. We know these are the examples of acids, right? And you can see oxygen is present in their molecular formula. So according to Lavoisier, acids contain oxygen. But then another scientist after him in 1811 questioned his theory, and he found HCl, HBr, HF, HI. These are all acids, and yet they do not contain oxygen. So Lavoisier's theory failed to explain why these acids do not contain oxygen. Correct? Hydrochloric acid, hydrogen bromide, hydrogen fluoride, hydrobromic acid, hydrofluoric acid, hydroiodic acids. These acids do not contain oxygen, and yet they are acids. Correct? Okay. Well, this Humphrey Davy, we will remember he on the later stages. Okay. जस्टिक लाइबिग in 1838 उसने एक और थियरी दी. What he suggested that acids contain one or more hydrogen atoms which can be replaced by metal atoms to produce salt. See this? Can you see this? Hydrogen, hydrogen, everywhere there is hydrogen. When this acid, if you react with metal, then this metal will remove hydrogen from here and produce salt and water. Alright? So salt is produced. Then such substances are said to be acid. But his theory also did not work for a long time. Alright? Yes, the most accepted theory about acid and base was given by Arhelius. Alright, it was given by Arhelius. Vante, S is silent, Vante Arrhenius. He was from Sweden. In 1884, he proposed one thing. From his study, he found that salts dissociate when they dissolve in water to give charged particles, which he called as ions. So children, you already know what are ions. Positively charged ions, negatively charged ions. You have learned them, and you have learned them by heart. Alright? Okay. This word ion for the first time was given by scientist Arrhenius in 1884. Let's take one example. Sodium chloride. It is one salt, correct? Let's split it here, this, into two ions. So when you add this sodium chloride salt in water, alright, what happens? Sodium ion is produced and chloride ion is produced. This is what Arrhenius found, discovered in 1884 through his activities, alright, through his experiments, that when salt is dissolved in water, it ionizes into cation and anion. Are you getting me? Further, in 1887, that means 3 years after, this idea was extended and he defined acid and base. Alright? And what is the Arrhenius acid and what is Arrhenius base? Alright? Any substance that ionizes when it dissolves in water to give hydrogen ion, it is said to be an acid. Example, HCl and HNO3. Children, at that time there were many theories, and these theories, though not very perfect, was accepted worldwide, and for that Arrhenius received a Nobel Prize in Chemistry in 1903 AD. Alright, let's try to understand the definition of acid as given by him. Here is HCl. क्या बोला Arrhenius ने? उसको dissolve करो पानी में. This is another way of writing the equation. Okay? I put arrow and on that I wrote H2O, which means this HCl is dissolved in water. You get H plus 1 ion and chloride minus 1 ion. Alright? Ionization takes place of HCl. Then next acid is HNO3, dissolve in water. Children, mostly the acids are soluble. Okay? So you get H plus 1. See, split kariye aap, split kariye. H plus 1 and nitrate. You know about these ions very well. So you get hydrogen ion and nitrate ion here. So what Arrhenius observed, if the substance is acid and if you dissolve in water, one of its ionization takes place. वो तो उसने 1884 में ही बता दिया था. But one of the ion is always H plus 1. And if this ion is H plus 1, then that substance is acid. You can see here, this substance is not acid because on ionization, H plus is not obtained. Is that clear to you, children? So we have many examples here. So I'll read Arrhenius acid once again. Any substance that ionizes when it dissolves in water to give hydrogen ion, it is said to be an acid. Example HCl and HNO3. By any substance, I have taken HCl. I am dissolving in water. Ions are produced. One of the ion is hydrogen. So this is acid. Is that clear to you? Okay. So moving on to the next one. What is Arrhenius base? Any substance that ionizes when it dissolves in water to give hydroxide ion. Children, ये मैंने already बता दिया है आपको previous session में कि यदि acid हुआ तो उसमें cation hydrogen ion is always present. और यदि बेस या अल्काली हुआ तो उसमें N ion OH hydroxide ion is always present. That is what he concluded from his activities, from his experiment. Say this, any substance that ionizes when dissolved in water give hydroxide ion, it is said to be base or alkali. Let's take the example NaOH. I'm going to dissolve this in water. This is another way of writing, as I said. Now, ये ionize होगा, split होगा. कहाँ से? What you are going to get? Na plus 1 or OH minus 1. You are going to get these two ions. You can see one of the ion, the N ion is hydroxide. Let's take the other example. KOH, dissolve in water. So we are preparing its aqueous solution. Alright. Split kariye. So you are going to get positive ion, cation, potassium ion, N ion, hydroxide ion. So you can see the N ions produced when these two substances are dissolved in water are hydroxide. Then such substances are called bases या alkalis. Is that clear to you, children? Good. All right. Moving on to the next acid-base theory, which became popular, and it was Bronsted-Lowry. You may write Lowry-Bronsted or Bronsted-Lowry. It was developed in 1923. Johannes Bronsted from Denmark, a Danish chemist, and Thomas Lowry, right, a British chemist. All right. Previously I said that they worked together. I'm sorry about that. They worked separately and proposed the same theory. दोनों की theory बराबर मैच हो रही थी. इसलिए that theory jointly came to be known as Bronsted-Lowry acid-base theory. Same year, the Arrhenius gave the theory, correct? Sorry, Lewis gave the theory. Same year. Arrhenius ने तो 1887 में दिया था. Alright. Bronsted-Lowry acid. अब कौन से substance को आप acid बोलेंगे? Alright. The substance which donates proton to other substance is known as Bronsted-Lowry acid. As for example, HCl and water. Alright. Okay. Now this is slightly difficult to understand. हमें इलेक्ट्रॉन डॉट स्ट्रक्चर में जाना पड़ेगा. ऑलराइट, चलिए हम पहले देखते हैं HCl. ऑलराइट, क्लोरीन, its atomic number is 17, so its electronic configuration is 287. So it has 7 free electrons. So I am putting those 7 free electrons here. 1, 2, 3, 4, 5, 6 and 7. So I have represented the free electrons by dots. All right. Now, one electron is shared by hydrogen. The hydrogen, the atomic number is 1, so it has one free electron. So this is the hydrochloric acid covalent bond. Covalent bond between hydrogen and chlorine atom. And which compound is this? HCl. Okay. Chalo. I am going to react this or dissolve it in water. See how water is formed. 8 is the atomic number of oxygen. So 2, 6 is electronic configuration. So it has 6 free electrons. 1, 2, 3, 4, 5 and 6. Correct? And yes, to complete the octet, it shares 2 electrons with 2 hydrogen atom. So this is H2O. हम जिसे water कहते हैं. Correct? Now, children, one thing you try to understand. What is proton? Proton किसे कहते हैं? Now you know any atom is hollow. In the center there is dense nucleus. Correct? Dense nucleus. And in the nucleus there are protons and neutrons. Hathi and genda. Right? Protons and neutrons. And in the surrounding, electrons keep on revolving just as the planets revolve around the sun. Electron એટલે એને હું કીડી કહું છું, right? Why proton and neutron I call them as hathi and genda? Because they have almost the similar mass. અને આને કેમ કીડી કહું છું? Because its mass is 1800 times smaller than the mass of proton and neutron. All right? Anyway, now this atom, say suppose it is of hydrogen, तो उसमें एक प्रोटॉन होगा, न्यूट्रॉन एक भी नहीं होगा और एक इलेक्ट्रॉन होगा. बट इफ दिस एटम गिव्स अवे वन इलेक्ट्रॉन, उसने एक इलेक्ट्रॉन दे दिया, तो हाइड्रोजन एटम, एज यू हैव लर्न्ड अर्लियर, टर्न्स इनटू हाइड्रोजन आयन. बाय लूजिंग वन इलेक्ट्रॉन इट गेट्स चार्ज्ड +1. आर यू गेटिंग मी चिल्ड्रन? याद आ रहा है आपको? सो एटम टर्न्स इनटू आयन बाय लूजिंग इलेक्ट्रॉन हियर, एंड व्हेन यू लूज इलेक्ट्रॉन इट बिकम्स पॉजिटिव आयन. अब ये आयन में है क्या? एक प्रोटॉन, उसके अलावा कुछ भी नहीं है. आर यू गेटिंग मी? सो दिस हाइड्रोजन आयन इज क्वाइट ऑफन कॉल्ड प्रोटॉन. उसे प्रोटॉन भी कहते हैं. नाउ लुक चिल्ड्रन, प्लीज ट्राई टू अंडरस्टैंड. जरा समझो हाउ द आयोनाइजेशन टेक्स प्लेस. इट्स नॉट गोइंग टू बी इजी. ये हाइड्रोजन यहां से एक इलेक्ट्रॉन ऑक्सीजन से लेता है. ऑलराइट, मैंने आपको एक एग्जांपल पहले भी समझाया था. आप 4 दोस्त 2 बाइक पे फिल्म देखने जा रहे हो, राइट? आपके पीछे जो बैठा था आपका दोस्त, उसने आधे रास्ते में बताया कि मेरे पास पैसे नहीं है टिकट का, राइट? आपने साइड पे गाड़ी रोक दी और 100 रुपीज जो टिकट का कॉस्ट था वो 100 रुपीज उसको आपने दे दिया और बोला कि आप जब आपके पास पैसे आएंगे तो मुझे वापस करना, राइट? ओके, नाउ यू रीच द थिएटर. आपने ही बोला, दूसरे 2 दोस्त को भी, तीनों को बोला चलो टिकट का 100 रुपया दे दो. सब ने 100 रुपया दिया. आपके दोस्त ने भी दिया, जो आपका ही 100 रुपया था उसने आपको दिया. ओके, आपने क्या किया? आपकी दोस्त की इज्जत बचाई. कैसे? वो पैसे देकर. बाकी 2 दोस्त को पता नहीं है कि आपने पैसा दिया था. जो अंडरस्टैंड? ओके, तो इस तरह यहां होता है. ये जो ऑक्सीजन है वो अपना एक इलेक्ट्रॉन हाइड्रोजन को दे देता है और हाइड्रोजन वही इलेक्ट्रॉन लेकर यहां शेयर कर देता है. सो यही हाइड्रोजन, ये इलेक्ट्रॉन जो उसको मिला वहां आ जाता है, राइट? आई राइट ऑन द अदर साइड, राइट साइड. ये O है, उसके ये 6 इलेक्ट्रॉन्स है, ये हाइड्रोजन है, ये हाइड्रोजन है, ये पहले से. अब ये तीसरा हाइड्रोजन यहां अपना इलेक्ट्रॉन लेके उसके साथ शेयर किया और इसका ये हाइड्रोजन यहां से निकल गया. सो व्हाट यू गॉट? क्लोरीन विथ व्हाटएवर डॉट्स आर देयर. ओके, सो दिस बिकम्स नेगेटिवली चार्ज आयन एंड दिस बिकम्स पॉजिटिवली चार्ज आयन. क्यों? क्यों ये नेगेटिव? बिकॉज इट हैज गेन्ड वन इलेक्ट्रॉन। ये क्लोरीन को हाइड्रोजन ने अपना इलेक्ट्रॉन वहीं छोड़ दिया, तो क्लोरीन के 7 इलेक्ट्रॉन्स की जगह पे 8 इलेक्ट्रॉन्स हो गए। सो इट हैज गेन्ड वन इलेक्ट्रॉन। सो व्हेन एटम गेन्स इलेक्ट्रॉन इट बिकम्स नेगेटिवली चार्ज आयन। आपको पता चला? एंड यही ऑक्सीजन ने हाइड्रोजन के एक दिया था, एक इलेक्ट्रॉन दे दिया था, तो वो पॉजिटिवली चार्ज हो गया। पॉजिटिवली चार्ज होने के बाद वही हाइड्रोजन उसके साथ एक इलेक्ट्रॉन शेयर करता है। चिल्ड्रन, दिस इज टेरिबल। ऑलराइट, आई होप यू ऑल आर अंडरस्टैंडिंग। सो ये H3O प्लस और ये Cl माइनस। सर आप तो बता रहे थे कि जब एसिड पानी में डिसॉल्व करो तो हाइड्रोजन आयन प्रोड्यूस होगा और क्लोराइड आयन प्रोड्यूस होगा। यहां तो कुछ और ही निकला। दिस इज कॉल्ड हाइड्रोनियम आयन। दिस इज कॉल्ड हाइड्रोनियम आयन। चिल्ड्रन, व्हाट हैपेंस हियर एक्चुअली? इनिशियली हाइड्रोजन आयन ही प्रोड्यूस्ड होता है, बट इट इज हाईली अनस्टेबल। वो फॉर्म में नहीं रहना चाहता है। इन प्रेजेंस ऑफ वाटर, वो पानी के प्रेजेंस में पानी से रिएक्ट करके हाइड्रोनियम आयन बन जाता है। चिल्ड्रन, मैंने बोला था हम देवी साइंटिस्ट को फिर से याद करेंगे। ये चीज देवी ने ढूंढी थी। दिस वॉज डिस्कवर्ड बाय साइंटिस्ट देवी। ऑलराइट, व्हाट ही डिस्कवर्ड? कि व्हेन एसिड आयोनाइजेस इन वाटर, हाइड्रोजन इज प्रोड्यूस्ड, बट वो ज्यादा समय टिकता नहीं है। Soon that hydrogen ion reacts with excess of water and turns into hydronium ion. तो वही चीज यहां हो रही है। See, अब क्या हुआ? इसने एक प्रोटॉन लिया के नहीं चिल्ड्रन? यहां दिस सेकंड रिएक्टेंट हैज रिसीव्ड वन प्रोटॉन। मैंने बताया ना, हाइड्रोजन आयन को हम प्रोटॉन कह सकते, तो उसको एक प्रोटॉन मिला। ये रिसीव्ड प्रोटॉन, सो दिस इज बेस, दिस इज ब्रॉन्स्टेड-लॉरी बेस। और ये HCl ने प्रोटॉन डोनेट किया, इसने प्रोटॉन दे दिया, सो दिस इज एसिड। सो हियर HCl इज एसिड एंड H2O इज वाटर। आर यू गेटिंग? सॉरी, H2O इज बेस। चिल्ड्रन, यू माइट से कि वाटर इज न्यूट्रल, but remember children, only pure water, the distilled water, is neutral. But if any form of salt is dissolved in it, it is either acidic or basic. Yes, water यहाँ base है, और कुछ जगह पे आपको basic nature में भी मिलेगा, acidic nature में भी मिलेगा, और neutral भी मिलेगा. Yes, neutral water is only when it is in its purest form. But if the water is impure, it is either going to be acidic or basic in nature. Here is one example. ये पानी है, this is water, and it is base because it receives proton. और ये HCl donates proton, so it is acid. All right. Let's take another example. NH3. याद करो, Arhelius. According to Arhelius, this ammonia is not base. But the truth is ammonia is also a base, and that limitation of Arrhenius was overcome by Bronsted-Lowry. Right? Okay. So let's see how ammonia is as a base. Now ammonia, nitrogen, its atomic number is 9. So electronic configuration is 2,7. So it has 7 free electrons. So here is nitrogen 1, 2, 3, 4, 5, 6. All right. Nitrogen has 7. So it is 2, 5. I'm sorry. The atomic number of nitrogen is 7. So electronic configuration is 2, 5. So it has only 5. 1, 2, 3, 4, 5, 6. मैंने 6 लिख दिया. इसको मैं अलग कर देता हूं. वो हाइड्रोजन के साथ शेयर करेगा. ये. All right. One hydrogen shares one electron with nitrogen atom. देखो 2, 4, 6, 8. आप रिवीजन वीडियो देखिए, ये बहुत डिटेल में मैंने समझाया है. सो दिस इज एमोनिया NH3. ऑलराइट, उसको पानी के साथ ये O, उसके 6 इलेक्ट्रॉन्स, और ये हाइड्रोजन और ये हाइड्रोजन. ऑलराइट, अब यहां क्या हो रहा है चिल्ड्रन? दिस हाइड्रोजन, इसके 6 है ना, 2, 4, ये हाइड्रोजन नहीं है बेटा. चिल्ड्रन, दिस इज नॉट हाइड्रोजन. 2, 4 और 6. ऑलराइट, चलिए. दिस टाइम ये जो नाइट्रोजन है अपना एक इलेक्ट्रॉन उसको अपने दोस्त को दे देता है. ऑलराइट, सो दिस becomes positively charged by losing. Children, be careful, the work is going to be untidy. Okay, ये N, उसके ये इलेक्ट्रॉन्स, ये इलेक्ट्रॉन्स, ये इलेक्ट्रॉन्स और ये इलेक्ट्रॉन्स. यहां हाइड्रोजन है, यहां हाइड्रोजन है, यहां भी हाइड्रोजन है. Now what happens children? ये not here, from here children. ये तो ऑलरेडी शेयर किया है, सो यहां से देगा वो हाइड्रोजन को. ऑलराइट, वो वापस, और वो हाइड्रोजन वो इलेक्ट्रॉन लेकर यहां आ गया. राइट, ओके. यही हाइड्रोजन यहां अपना इलेक्ट्रॉन उसको जो एमोनिया ने दिया, नाइट्रोजन ने जो दिया, वापस लेकर आया और यहां नाइट्रोजन के साथ शेयर कर लिया. सो इसने एक इलेक्ट्रॉन दिया था, सो इट बिकम्स पॉजिटिवली चार्ज आयन. और यहां से एक हाइड्रोजन चला गया, सो O 2 dots, dot cross with hydrogen, 2 dots and dot cross, but no hydrogen here. Okay, so यहां उसने एक इलेक्ट्रॉन पाया, so this becomes negatively charged. अब यहां देखो, हाइड्रोजन ने वाटर ने H2O ने यहां से एक हाइड्रोजन आयन डोनेट किया, दैट मीन्स प्रोटॉन डोनेट किया. So this water is acid here and this one received the proton, so that is base. So here, according to Bronsted-Lowry theory, ammonia is base. Is that clear to you children? Children, I have made little bit work untidy, but hope you understood. Okay, chaliye. Now here, so in this case the water is acid, in this case the water is base. So water can act as acid in one situation and base in other situation. Such type of substances are called amphoteric substances. So water is amphoteric. Okay, water is amphoteric substance. Okay, children. Now what happens when water reacts with water, children? H2O in liquid form reacts with H2O in लिक्विड फॉर्म. चिल्ड्रन, इसको समझो एसिड और इसको समझो बेस. करेक्ट. इसने प्रोटॉन डोनेट किया, मतलब हाइड्रोजन आयन, तो 3 हो गए, 2 के H3O और वो पॉजिटिव आयन, इसमें से एक निकल गया, सो OH, so it gives you hydroxide ion. So when water reacts with water and if ionization takes place, all right, then you will get hydronium ion and hydroxide ion. So this hydronium ion shows presence of acid and hydroxide ion shows presence of base. इसने डोनेट किया तो it will be acid, इसने रिसीव किया तो it will be base. All right, I hope you understood children. So that's all for today's session. We will conclude this and continue in the next session. Still the theories will continue. Children, believe me, all these things are not given into your textbooks. So don't worry about this if you don't want to remember. But any objective can be asked. And for that, yes, I have to say you will have to remember. So see you in the next session. Till then, goodbye.